Section 7 has us looking graphing trig functions. So if you think back to Section 6, where we dealt with periodic functions, we would say that our trig functions are also periodic functions because after a certain period of time, they start to repeat themselves. Your trig functions actually come from your unit circle. So I have my unit circle up on the side here to the right, but it can also be found on page 832 in your books. So what we're going to do before we even start to graph trig functions and how they really look, we're going to focus on the most basic trig functions. And we're first going to start by graphing y equaling sine of theta, and we will graph y equals cosine of theta. In this video, we're just going to focus on what does sine of theta look like. Okay, so again, thinking back towards thinking back towards section 6, where we dealt with periodic functions, we said that sine of theta, looking on the unit circle, was the same thing as our y values. So we're going to look at all of our y values in order to make this work. I'm not going to use every line on here to make our trig function. We'll just pick out a few spots that will make this work. Okay, so what I really want to do is I want to focus on what is sine of 0 degrees, what is sine of 45 degrees, sine of 90 degrees. You can start to see the pattern. I want sine of 135 degrees. I'm going to keep scrolling down. Sine of 180, sine of 225, sine of 270, and two more, sine of 315, and sine of 360. Once I get to 360, we really should start to repeat ourselves. So in this case, our degrees is going to be considered our x value, and our height is whatever the y value corresponds, since we say that sine of theta in here is the same thing as the y value. Okay, so looking at sine of 0 degrees, here's 0 degrees, my y value is 0, so we're at height of 0. Sine of 45 degrees, you can take your calculator and you can take the square root of 2 divided by 2. That is about 0.7-ish something. So we're going to say, I'll just keep it as the square root of 2 over 2 for now, but realize that it's about 0.7. Actually, I'll do it in my calculator here real quick, just to get a decimal. Square root of 2 divided by 2 is the same thing as about 0.71. Sine of 90, our y value is 1. 135, our y value is about, or square root of 2 over 2, which is 0.71 again. Sine of 180, y value is 0. Sine of 225, we have negative square root of 2 over 2, which is negative 0.71. 270, y value is negative 1. 315, negative square root of 2 over 2, which is negative 0.71 again. And then all the way back to 360, we are at a height of 0 again. So if we were going to make our actual trig function out of this, this would be considered my coordinate plane. The highest we ever got to was a height of 1. I'm going to use, and the lowest we ever got to was -1. We also hit 0.71 quite a bit and -0.71. The spots that we paid attention to were 45, 90, 135, 180, 220, or yeah, 225, 270, 315, and then all the way back to 360. So now we should be able to take our spots and graph them. So at 0 degrees, we were at a height of 0. 45 degrees, we were at 0.71. 90, we were at a height of 1. 135, we were back at 0.71. 180, we were at 0. 225, we're at -0.71. 270, we were at -1. 315, -0.71, and then 360, we were back at 0. So to finish out, our graph would look something like this. Oops. This is kind of difficult for me. That would be one period or one cycle of a sine function. We'll learn eventually how we can manipulate this sine function, but as its most basic, that's what sine of theta is going to look at. One cycle of sine of theta would look like.